Welcome to Web Handling. I am very excited to welcome back on our program none other than the internationally recognized author, teacher, and expert, Dr. Roysum. As a continuation of this month's theme, we will be again talking about failure. We feel this is an important topic that's been underappreciated in industry, and we are doing our small part to call attention to its life's lessons. Without further ado, let's get started. First, let's recall that a war story is a real event where the wise can learn from the mistakes of others rather than have to make them themselves. In this story, we will ask Dr. Roysum about his most expensive professional mistake and what he learned from it. Welcome back, Dr. Roysum. Thank you, David. I'm happy to be back to share some of my life experiences. Can you tell our audience a little bit about your most expensive professional mistake? Certainly, though it will be a bit technical. Is that okay? I'm sure that for some of our audience that won't be a problem, but maybe we should start with some background first. The problem I was working on was an air bubble behind a winding nip. We know that this is entrained air versus some other mechanism, primarily because of its speed dependence, but as well as on its recent worsening when the mill began running a smoother and more closed sheet. The problem is somewhat rare, but has been found in both film converting as well as in the paper industries. It has been steadily getting worse as everyone tries to up their speed on their lines. We know one effective solution, that is a special type of wide shallow grooving as shown in blue. Note this is entirely different than the narrow ventagrooving that is quite common in web handling to handle air between a web and a roller, as shown in green. The air that we're talking about here is between the web and the web, inside the winding roll. The mechanics are that at a wide groove, there's no local nip, and that allows the air that would otherwise be trapped by the nip to bleed through. As the roller or drum rotates, the spiral vents the air across the width of the winding roll. This is as much as I can explain here because the topic is quite advanced. It is only discussed in two places in the literature. One is the paper I give at the international conference listed below. The other is on some advanced winding classes that I teach. Is this something you'd be willing to share with the audience? Oh, for sure. Just email me at drroysum@aol.com with winder grooving in the subject line. In order to specify grooving, you must specify depth, width, pitch, direction, shape, and other parameters. Those are far too many degrees of freedom, so we must make some assumptions to get started. The drum already had a wide, shallow groove, though it wasn't enough. So we fixed the pitch to match the current drum, allowing us to regroove right on top of the old grooves. All we had to do is to figure out how wide and how deep. We decided to go slightly wider and slightly deeper with the new pattern. There are two options once one decides grooving geometry. One is to build. The other is to rebuild. The mill decided to build a brand new spare drum with a brand new grooving pattern rather than taking it extended down to regroove the old one. In today's dollars, that costed about $250,000 installed. Okay then, but don't keep us in suspense. Did it work? Unfortunately, it only helped a little bit, not nearly enough to be worth the effort. We guessed wrong about how much more grooving was needed for this new grade. In other words, we failed. Yikes, that hurts. But the real question is, did you learn anything from this experience? Yes, I did. The next time I worked on that problem, I simulated the grooving pattern first with duct tape. Pitch, width, and even depth is easily enough simulated with most patterns. Depth is an interesting parameter. Just as making the pitch and the width too large, depth can be bigger than necessary and can cause problems. To simulate depth, we first try one wrap of tape and observe the results. If the improvement is seen, or even if not, we will try a second wrap laid on a spiral right on top of the first one. In this very specific application of a high-speed two-drum winder paper winder, the equivalent of 3 wraps of duct tape seemed to be the sweet spot for depth. Since you are obviously aware of taping to simulate grooving, why didn't you use tape to simulate grooving on this two-drum paper winder application? Well, David, I did initially consider using duct tape. However, this can be very tricky and possibly even dangerous to do in the paper industry. If that tape lets loose, running 20,000 pounds of paper rolls running at 8,000 feet a minute, the result will be a web break at best and possibly even a winder throwout or wreck at its worst. No one, including myself, was willing to take a chance of the tape letting loose. So, can you share with us how to tape drums most safely in this kind of application? Certainly, David. First, you should only tape 1/2 of the drum. Readers can comment below to guess as to why this is the best way to do a trial such as this. Second, you apply a tape on a spiral, though web handlers know that this spiral is strictly for convenience, has nothing to do with function. Third, it is very important that the trailing edge of the spiral of the tape is in the middle of the drum so it doesn't come off. Fourth, the leading edge of the tape that is off the web run so that it doesn't catch on anything, even air. That outside leading edge is then secured with a circle band of tape, again with the trailing edge not going into the wind. Fifth, you can break down even with a tiny bit of exposed glue on the edges of the tape. Thus, it is a good idea to powder to spoil the adhesive. So, is there anything else that you've learned from this experience? Well, I'm not sure I learned anything new, but rather reinforced things that I already knew. That is, science by consensus doesn't always work. Even if the mill and I, as well as a winder engineering manager, all thought we had enough grooving with the new pattern, the real world will form its own opinion. Finally, we are all tempted to live with the devil we know, in this case regrooving a drum, rather than the one we don't, in this case whether tape will hold at 8,000 feet a minute. Very interesting. So, Dr. Roysam, do you have any final general thoughts to share about your experiences with failure? Certainly. The thing to note is that professional failure, both big and small, is pretty much inevitable. If you work at the level of senior project engineer or above, and you avoid failures at the levels described above, you are either both good and luckier than most, or you've not tried hard enough. Failures at a much smaller level are much more common. For example, you might study a problem and not be able to figure it out, or you figure it out but you can't sell the solution to your boss, or economics or physics does not allow a solution at this time. Thank you so very much, Dr. Roysum, for sharing with us some of your very valuable personal experiences that we can all learn from. Stay tuned for next week's show, where we will again talk about failure. This time, it will be cognitive dissonance of a customer who is unwilling to accept that they are the problem, despite ample evidence to the contrary. If you have a topic you would like to hear about, let me know in the comment section below. If you found any of these stories to be interesting or useful, please like and share and subscribe. And remember to check out the show notes for surprises. See you next time.